It's surprising how many people take illustrations in popular science articles seriously, even though the sizes and distances shown are usually far from accurate. In reality, if the Sun and Earth were placed next to each other, the size difference would be staggering. Hello and welcome to Z. Please don't forget to subscribe and hit the bell icon. The Earth's diameter is 12,742 kilometers, while the Sun's diameter is a massive 1,392,700 kilometers. This means that 109 Earths could line up across the Sun's diameter with room to spare. This is impressive, but to really grasp the Sun's scale, let's consider its circumference. Earth's equatorial circumference is 40,075 kilometers. A passenger plane flying at a typical speed of 800 kilometers per hour would take about 50 hours, or roughly 2 days, of non-stop flight to circle the Earth. Now imagine flying the same plane around the Sun. The Sun's circumference is 4,379,000 kilometers, meaning the flight would take about 5,473 hours, or 228 days. That's more than 32 weeks, or about 8 months. When we talk about volume, the numbers become even more mind-boggling. The Sun's volume is about 1.412 times 10 to the power of 18 cubic kilometers. To visualize this, roughly 1.3 million Earths could fit inside the Sun. But even with its immense size, the Sun is just an average star. There are much larger stars, including giants, supergiants, and hypergiants. Let's look at hypergiants in particular. KY Cygni. While the Sun could fit 109 Earths across its diameter, KY Cygni could hold 1,000 suns. Located about 5,000 light-years away in the star cluster NGC 6913, KY Cygni's brightness ranges from 138,000 to 270,000 times that of the Sun. Yet, it's not visible to the naked eye because of interstellar dust. KY Cygni's surface temperature is much lower than the Sun's, at around 3,550 Kelvin, and it is a variable star, meaning its size changes over time. This makes studying it challenging, but scientists generally agree it is one of the smallest hypergiants. VY Canis Majoris. For a long time, VY Canis Majoris was considered the largest star. Located 3,800 to 5,000 light-years away in the Canis Major constellation, this star's radius is estimated to be 1,420 times that of the Sun. If placed in our solar system, it would reach as far as Jupiter's orbit. Despite its size, VY Canis Majoris is only 15 to 25 times the mass of the Sun. Its low density, about 100,000 times less than Earth's atmosphere, explains this. As the star nears the end of its life, scientists believe it will explode as a supernova or hypernova within the next 100,000 years, leaving behind a black hole. Stephenson 2-18. Currently, the largest known star is Stephenson 2-18, a red hypergiant located 18,910 light-years away in the constellation Scutum. With a radius approximately 2,150 times that of the Sun, this star would stretch beyond Saturn's orbit if placed at the center of our solar system. Stephenson 2-18 is 437,000 times more luminous than the Sun and has a volume 10 billion times greater. Yet, it is only about 50 times as massive as the Sun, with an extremely low density like other hypergiants. These stars form in regions rich with material, but they live relatively short lives, ending in massive supernova explosions. Luckily for us, the Sun was born in a calmer part of the galaxy, far from these enormous stars. While we can observe them from a distance, Earth's location has provided the perfect environment for life. Stars are the most fundamental building blocks of the universe, scattered across the vastness of space. They vary immensely in size, luminosity, and composition, but it's easy to overlook the vast differences between them when viewed from Earth. While our Sun is a modest star at the heart of our solar system, there exist stellar giants whose size and scale boggle the mind. Some stars are so vast that they could engulf billions of suns, redefining our understanding of how massive and powerful stars can become. This essay explores how astronomers measure stars, compares the sizes of the Sun and these superstars, and discusses the implications of these colossal entities. Understanding star sizes, from dwarfs to supergiants. Stars are classified into various categories based on their size, temperature, and brightness. The smallest stars, known as red dwarfs, are just a fraction of the size of the Sun, often less than half its diameter. On the other end of the spectrum, there are red and blue supergiants, which are some of the largest known stars in the universe. These supergiants can be hundreds to thousands of times larger in diameter than the Sun. However, the absolute largest stars are known as hypergiants, stars so massive and voluminous that they can span more than 1,000 times the radius of our Sun. When comparing stars, astronomers use the term solar radius to measure their size relative to the Sun. For example, Betelgeuse, one of the largest visible stars, has a radius about 1,400 times that of the Sun. However, there are stars that dwarf even Betelgeuse. One such colossal star is UY Scuti, located around 9,500 light-years away in the constellation Scutum. It has a radius approximately 1,700 times that of the Sun, making it one of the largest stars ever discovered. The Sun, a modest star in the cosmic scale. Despite its importance to life on Earth, the Sun is not particularly large compared to other stars. With a diameter of about 1.39 million kilometers, 864,000 miles, it is categorized as a G-type main sequence star, often referred to as a yellow dwarf. The Sun accounts for 99.86% of the total mass of our solar system, yet it is relatively small in the context of the universe. The Sun's radius is about 696,340 kilometers, 432,685 miles, making it a middling star in terms of size. If we compare the Sun to UY Scuti, the size difference is staggering. If UY Scuti were placed at the center of our solar system, it would extend beyond the orbit of Jupiter, swallowing Mercury, Venus, Earth, Mars, and even the asteroid belt. The Sun's size pales in comparison to such a hypergiant, demonstrating how stars can vary enormously in scale. The largest stars, titans of the universe, stars like UY Scuti or VY Canis Majoris, another contender for the title of largest star, have masses and radii that stretch the limits of what we previously thought possible. VY Canis Majoris, for example, has a radius about 1,500 times that of the Sun. The mass and volume of these stars are so vast that their sizes are difficult to comprehend. To put it into perspective, while the Sun has a volume of about 1.41 times 10 to the 18th cubic kilometers, UY Scuti's volume is roughly 5 billion times greater, meaning that around 10 billion suns could fit inside UY Scuti. It is important to note that when we discuss stars being larger than the Sun, we are often referring to their volume or radius rather than their mass. These hypergiants are not necessarily the most massive stars. In fact, they are often less dense than smaller stars. The immense size of these stars is largely due to their outer layers, which are extended over vast distances, making them incredibly bloated compared to denser stars like neutron stars or white dwarfs, which are small but extremely compact. Implications of massive stars. The size of a star is not just a fascinating detail, but also plays a crucial role in determining its lifespan and ultimate fate. Larger stars burn through their fuel much faster than smaller stars. While the Sun, for instance, has a lifespan of about 10 billion years, a hypergiant like UY Scuti is expected to last only a few million years before exhausting its nuclear fuel. Once they run out of fuel, these stars typically explode in spectacular supernovae, leaving behind either neutron stars or black holes. The presence of hypergiants also has implications for the evolution of galaxies. These stars play a key role in the process of nucleosynthesis, where heavier elements are formed in their cores and distributed throughout the galaxy when they explode. This cosmic recycling process enriches future generations of stars and planetary systems with the elements necessary for planets and even life to form. Conclusion. The sheer diversity of star sizes within the universe reveals the incredible range of cosmic phenomena that exist beyond our solar system.